Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on equivalent fractions. So we learned about what fractions were last time. Fractions are parts of a whole. They're numbers written like this, something over something. A, the number on top is called the numerator, and B, the number on the bottom is called the denominator. So when we say two fractions are equivalent, we mean this times this is equal to that times that. Now that sounds a bit confusing, but what it means in practice is really simple. Two fractions are equivalent if their numerators and denominators have been multiplied or divided by the same number. So what do I mean by that? Well, let's look at these two fractions, 5 over 12 and 10 over 24. Are they equivalent? Well, to go from 5 to 10, I've multiplied by 2. I've multiplied the numerator by 2 to get the numerator of this fraction. To go from 12 to 24, I've also timesed by 2. Because what I've done to the top is the same as what I've done to the bottom, I've multiplied top and bottom by the same number. These two fractions are equivalent. So we put an equal sign between them. Now let's look at these two fractions, 8 over 15 and 24 over 30. So to go from 8 to 24, I've actually multiplied the numerators by 3. But to go from 15 to 30, I need to multiply the denominators by 2. See, I haven't done the same thing to the top and the bottom. I've multiplied the top by a different number to the bottom. So these two fractions are not equal. That's what this symbol means here. 8 over 15 and 24 over 30, they are not equivalent. So let's look a bit more at what it actually means if two fractions like these two are actually equivalent. Well, when we say two fractions are equivalent, we mean they're equal. That's why I put the equal sign between them. It means that they have the same value and occupy the same position on the number line. So we looked at number lines in previous video. So I've divided this top number line into quarters and this one here into eighths. So notice here, 1 over 4 and 2 over 8 occupy the same position on the number line. 1 over 4 and 2 over 8 are equivalent fractions. That means they are equal to each other. They have the same value. If you eat a quarter of a pizza, that's exactly the same amount as if you have 2/8 of the pizza. Both of these are equal to 0.25, and that's why they're the same position on the number line. You can see also 3/4 and 6/8. They occupy the same position on the number line. And that's because of what we were saying before. We've multiplied the numerators by 2, and we've multiplied the denominators by 2. We've multiplied top and bottom by the same number, therefore these two fractions are equal. They have the same value. They're both equal to 0.75. If I said, 3/4 of the class passed their maths test, that means exactly the same thing as if 6/8 of the class passed their maths test. So we can also view equivalent fractions on this thing here called the fraction wall. So how does this work? Well, we've divided here down the bottom this into halves. So we start at 0, and then 1 is here, and this fraction here is a half. So if we go up to the quarters, this would be 1/4 here, 2/4, 3/4, and then 1 again. So hopefully you can see here, this one and this one are the same. A half and 2/4, they are equivalent fractions. They're both equal to 0.5. There's other pair of equivalent fractions. See this fraction, if I'm going up by quarters, it's 1/4, 2/4, 3/4, 4/4. This number here is 4 over 4, but 4/4 is equal to a whole because you can see these are at the same position on the number wall. So 4 over 4 is equal to 1. So that's what we mean by equivalent fractions. They have the same value. They're both equal to the same thing. Here they're both equal to 1 whole, and it means they have the same position on a number line or a fraction wall. But of course, not all fractions are equal. So equivalent fractions can actually be used to help us compare fractions. When we say compare fractions in maths, it doesn't mean the same as when you say compare in English. We're not just writing about how they're similar. When we say compare fractions in maths, we mean determine which fraction is larger or smaller. It's like compare your maths results with your friend. You see who did better. So to compare fractions, we can use the equal sign that you've seen before, or these two symbols here. Greater than, less than. So this arrow greater than points to the right, because as we go on the number line, numbers are getting greater as we go to the right. Similarly, less than points to the left, because as we go to the left, numbers are getting smaller. So if a number is to the right of another number, it is greater than. So for example, if we see on this number line here, clearly 7/8 is greater than 5/8, because 7/8 is to the right of this. Now, when you're deciding which of these symbols to use, view this like a crocodile's mouth. So the crocodile eats the bigger number. So 7/8 is the bigger number, so we draw the crocodile's mouth here. So just think of it like that. 7/8 is greater than 5/8. So using both of these number lines, for example, we can compare the fractions, say 1/4 and 3/8. So 1/4 is over here, 3/8 is to the right. 3/8 is larger than 1/4 because 3/8 is further right. So the crocodile eats the bigger number. This time it's going to point this way. We want the crocodile to eat the bigger number. So this statement says 7/8 is greater than 5/8. This one says 1/4 is less than or equal to 3/8. So this is all well and good to compare fractions, decide which is larger, but you won't always have a number line or a fraction wall to help you. So we now need to look at a different method for comparing fractions. So because we won't always have the number line or fraction wall, what we're going to need to do is look at the denominators, which is the bottom number of the fraction. Now, fractions are really easy to compare if they have the same denominator. If you've got 3/5 and 4/5, well, clearly having 4 of something, 4/5, is more than 3/5. That's easy. So crocodile eats the larger number, it goes like that. 3/5 is less than 4/5. Similarly here, 8/11 is clearly more than 7/11. So we want the crocodile to eat the larger number. This says 8/11 is greater than 7/11. Having 8 of something, 8/11ths, is more than having 7 of something, 7/11ths. That's really simple. But when the two fractions are here and they don't have the same denominator, they're not actually easy to compare. So when that happens, we need to use equivalent fractions to make them have the same denominator. So what we're going to do is we're going to find a fraction equivalent to this and equivalent to this that have the same denominator. So the denominator I want my fractions to have is the lowest common denominator. It's the lowest common multiple of this number and this number. So the lowest number divisible by 6 and also divisible by 12 is 12. So what I can do is I can multiply this denominator here by 2, and it will make this have a denominator of 12. Then these two will have the same denominator. They'll be easy as to compare. But what did we say before about equivalent fractions? I can't just times the bottom by 2. What I do to the bottom, I need to do to the top. I want to find an equivalent fraction. I don't want to change the value of this fraction here. I just want to find another fraction that's equal to it that has denominator 12. So if I times the bottom by 2, I need to times the top by 2. So 5 times 2 is 10, and 6 times 2 is 12. So I'm going to leave the second one alone. 5/6 and 10/12 are the same. They have the same value. They are equivalent fractions. Now, comparing these two is really easy because they have the same denominator. So clearly, 10/12 is less than 11/12. Crocodile eats the larger number. So we're going to do something similar here now. Comparing 3/5 and 5/8 is hard. It's hard to tell, is this one bigger or is this one bigger? The reason it's hard to tell, they have different denominators. So what I need to do is find a fraction equivalent to this, find a fraction equivalent to this, so that they have the same denominator. So what do I want the denominator to be? Well, the lowest common denominator is the lowest common multiple of 5 and 8. The lowest common multiple of 5 and 8, the lowest number divisible by 5 that's also divisible by 8 is 40. So what I want to do is I want to take my fraction 3 over 5 and I want to write it as something over 40. And then I want to take 5 over 8 and I want to find an equivalent fraction whose denominator is 40. So remember what we said about equivalent fractions. What you do to the bottom, you must do the top. So to go from 5 to 40, I need to times by 8. So that means I need to multiply the top, also by 8. So 5 times 8 is 40, 3 times 8 is 24. 3/5 and 24 over 40 are equivalent fractions. They're both equal to 0.6, have the same value. They'd be found at the same position on the number line. So to go for this one now, to go from 8 to 40, I would need to multiply by 5. So that means I would also need to multiply the numerator by 5 because I want this fraction to be equivalent to this fraction. So 5 times 5 is 25. 5 over 8 is equal to 25 over 40. They are both equivalent fractions. They are both equal to 0.625. Same value and everything. So 3/5 is 24 over 40. 5/8 is 25 over 40. Clearly this one is bigger. 25 over 40 is bigger than 24 over 40. So remember, the crocodile eats the bigger number. I want the crocodile to eat the 5 over 8. So we go like that. So that says 3/5 is less than 5 over 8. Reason? Because 3/5 is 24 over 40, but 5/8 is 25 over 40. And when fractions have the same denominator, they're very, very easy to compare. So this would be a lot quicker than drawing up two number lines, dividing it into fifths and dividing it into eighths. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.